All right. I thought I'd start out by some debugging metaphors to see if I can get us into debug mode. So I'd like to thank you all very much for choosing to step into this session. I hope that some of the contents will interest you. If it's known before, you can of course step over certain parts, but I hope you don't step out. Now, as this interactive debug session runs on rather limited hardware, there is of course the danger that I could get suspended or disconnected, but hopefully never terminated. So, my name is Martin Skarsaune. I'm a Java developer, like I guess most of the audience here. I spend a lot of my time debugging, so I feel it's well time spent looking at some debugger features. I myself like to look at how others do stuff, so I thought I would show some debugger features and different strategies for using them. Yeah, so I'm a Java developer. I work for a company called Contega in Norway. Usually I don't mention that too much, but this year there's actually a reason why we got some publicity. Because this summer some colleagues of mine developers had to be actors for a day. We made a recruitment video, and after a week or two it went viral, so we had like 18 million views. So after the presentation you could Google up the mysterious life of developers if you want to laugh. I think it's quite funny. And it's also a bit fun with the reactions. I think most Scandinavians get that this is satire and not how we really work, but I don't think everybody gets that. Talking about funny videos, I'm also part of the Java community in Norway, and we have a conference. I don't know if anybody has seen any of these videos. And the reason I take the opportunity to mention this when I have a room full of, I guess, many Scandinavian Java developers is that we're very eager to get input from people. It's a good platform to get started sharing knowledge. We have 10 minutes talks, 20 minutes talks, 45 minutes, 60 minutes workshops. And if you're not comfortable speaking English, we have a local content as well. So we usually have call for speakers from February to April, so you can look into that. All right, so I have then tried to organize some contents based on what I found most useful and perhaps a bit underused features of the debugger. So we'll start out at looking at actively using code evaluation during your debugging session. Then we'll look at all the ways you can control steps and breaks so that you don't have to go to too many detours. We also look at how you can do some tricks to make your application do something else than it would really do, maybe to simulate some failure scenario or something. We can look at keeping track of classes and objects and customize views and so on. And so this is sort of ordered by relevance, I think. So if you don't cover all of it, that's fine. I just learned that we should not go over time. So I'll aim at 40 minutes and we see how far we get. Also, I will be spending most of my time at my computer, hands-on. So please don't feel shy if things are too quick, unclear, or you have some opinions about something, you can shout out, and we can try to deal with it straight away. It's easier than to take it at the end, but you can also, of course, ask general stuff at the end. One notice is that I will use a bit limited setup today. Just one thing to keep in mind, I guess, normally when you debug, you will have one or more large screens. So I would usually take some care into placing stuff where I want them, so you don't need to do too much switching between views. Yeah. Just one before we start with the stuff. I have some opinions on when you are doing local development on your local computer. You have your IDE. Is there any reason not to launch in debug mode? And I have, for instance, if I have IDEA and I want to run some Java application, there is actually now I'm using 2.17.3, which is early access. And there is a new thing here, because people may be concerned that there's a lot of overhead involved. So now there's actually a measurement from the IDE point of view. And we can see that just by running this evaluation, we've not placed any breakpoints, we've not done anything, so we've not actually had any overhead. And as long as you're running a debug, if you discover something, you have the ability to set breakpoints and so on. And you get hot code replacement if you figure out you need to change something. You can watch the threads and so on. So I normally always launch in debug, whether it's units test or whatever. If you're worried about breakpoints, you can easily mute them, so they will not disturb the program if you left some breakpoints somewhere. And you can also tell it to unmute the breakpoints when this session finishes. So if you're able to see it, when I stop this program, this mute button comes off again. So at least from my point of view, I like to start things in debug, because then I have the ability to do it. Yeah. So code evaluation. Many of you use it actively today when you debug. Actually, everybody uses it without really knowing it, but we can actively use it as well. So let's just take an example here. For instance, here we have some operators. If I just simply place my cursor over an operator, it will then, after a hover timeout, it will evaluate this code for me. I can also, if I have some other example, if I just keep Alt pressed, this is in IDEA, so I can just highlight any expression, click, and have it evaluated in line. And in this case here, so if we know that all of these expressions are functional with no side effects, for instance, if you spent a long time to get to one point, here we could sort of look ahead to see whether things behave the way we expect, and then maybe decide where to step in and so on. Now we see we have some overhead. Another cool thing is that there is in fact nothing that's private. For the debugger, these are all objects that we have access to. So I can traverse a chain of private objects, getting into internal stuff of things, and I can even then say that I want to evaluate an expression from this point. So now I traverse several private variables, and I can even evaluate a private method within there. Nothing stopping me from doing that. So just to keep in mind, if you have like some closed source stack, or you use Spring or some frameworks, and you struggle with what's going on with the debugger, you can always get inside. You can inspect the state, and you can even manipulate the objects, whatever's hiding behind there. Yes. Another little trick is if you're aware of what's called conditional breakpoints. I have a conditional breakpoint here that you can also, here you have a code editor similar to what we just saw, that we could evaluate arbitrary code. You can actually do the same in an conditional breakpoint. So here I actually just inject some code and answer false. So this breakpoint will not actually stop, but it will sneak in some behavior into my application. So if I run this now that it's enabled, we'll see that I get all this logging output. For instance, if this was some third-party library that I had no access to. But what you should then know is that you see that I've done 1,000 iterations on purpose, and we see that it spends quite a lot of time. So there's a significant overhead to this, but it's a trick you can use. And I guess also the overhead counter would show this. Right. So now we've seen. Yeah, in Eclipse it's more or less the same. You can, highlight any code in the editor. If you want to do the sort of free form like we had in this box in IDEA, there's a view called display where you can enter certain code and have it evaluated. You can also, in both IDEs, you can convert this to an expression. Just remove some old stuff here. So now it's an expression with a magnifying glass that keeps track of it, but I can then in turn turn it into a watch expression, which is something that will be invoked in the context. So whenever you stop at the breakpoint, this code is evaluated again. One difference in Eclipse here is you can also break within evaluations. So if I placed a breakpoint here and I try to inspect this piece of code, we see that it will hit our breakpoints even within evaluations. It does not work on 2 levels. Then it says you cannot do nested evaluations, but sometimes you have, like you can, from a top view of code, you can simulate a request or something, and then you could still be able to debug within that. And sometimes you have you figure stuff while you're testing, and you want to play around with that independent of your debugging session. So you have what's called a scrapbook. So there are some areas of code that I rarely get on my first attempt. For instance, reg expressions or something. So here you can type. Oh yeah, I have to resume that one. So here you can then type any arbitrary Java code and play around with it. And then when you get it okay, you can put it into your unit test or whatever. But you have, and also, for instance, I do some integration work. Sometimes I need a valid Java UID. I can simply have this little snippet that creates it for me. So I'm now working in a project where we use IDEA, and I usually have just an Eclipse around just to do this. But in this EAP, there's a new thing which says you can open a JShell console. JShell is the new REPL for Java 9, so it's also integrated here. So I could then be able to do the same we just saw, and simply press play here, and we have this console down here, and this editor for doing code, and you can then also use the class path of your current project. Okay, I think that's more or less it. Yeah. All right, controlling steps and breaks. First, I would like to focus on a feature that is less useful than it used to be, but it's still good to be aware about it. A good example is I have some reflection code here, and I used what's called step filters. I can maybe show the effect first. So if I choose to step in here, we see that I get straight to my own code. And that is because I've set up step filters to avoid the Java Lang packages. And you also see here in the stack here that we just went past 4 levels of code and came straight into our own code. And you see also here in the stack here, you have the coloring yellow for library and green for test code, which we can use this filter to avoid. So it's often good to have some sensible step filters. You can then also add stepping filter for various stuff that you often run into and you're not interested in. I will show later why they're often not as important as they used to be in the moment. Yeah, you have the same functionality in Eclipse. In addition to all the settings, you can also turn the step filter functionality on and off with all the settings, whether you want it or not. Yes. Then we have. So if we had this situation here with a long line with a lot of calls, and we're not interested in stepping in and out of all this individual stuff. We have one particular place we want to step into that's interesting. You can do what's called smart step into, shift F7 in my case. So then we get this drop down here, which shows the options and highlights. So for instance, if I want to go here, it will step straight in there and skip all the others on the way. You don't need to set an extra breakpoint or anything. You can do that by stepping. We have the same in Eclipse, but I like to use it in a different way, because here it's called step into selection, so you can place a cursor and do step into selection. But you can also just keep Alt and Command pressed in my case, and just point and click, and we go straight there. So you get this nice point and shoot sort of feeling. Yeah, and then we have the whole subject of lambdas, which has been a source of frustration for a long time with regards to debugging. You can now, so if we enter a line which some lambdas, you can see that if I then do smart step into, we will be presented with options of stepping into various lambdas on this line. Also, if we try to attempt to set a breakpoint, we also get an option to set breakpoints within the lambdas. But in this case, it's a stream, so it's still very frustrating to be stepping in there or breaking. And then we have this thing here. If you can see it, it's a sort of a stream evaluator. And since streams are typically functional, here it doesn't matter if the compiler, the debugger evaluates this for us, because it has no side effects. So we can then follow the value of these objects, and you can inspect the results and so on. Do whatever you can in a variable holder for this, so we can see the result of this whole operation, which is nice. Because you can get into trouble with streams, or sometimes they can be pretty hard to understand if somebody else wrote it. So at least here you can follow the behavior. Yeah. Not this particular one, no. What you can say is that when the compiler compiles the code, each lambda will be will be turned into a separate method if you see in the class file, and the line information follows that method as well. So you can use line breakpoints also for IDEs that don't support lambdas, but it's a bit less precise for dealing with that. Let me just see. Yeah, well, I have one little idea when it comes to exception breakpoints. I suppose if you're aware of them, exception breakpoints enable you to get a snapshot of the system that the moment the exception was thrown, not when you caught it. So exception breakpoints are usually good for finding out exactly how a situation let me see, happened. But if you have something like, okay, let me see, that was too successful. It wasn't supposed to be that easy. But for instance, if you want to break on something like a null pointer, class exception, IO exception, something like that, you will never get anywhere because this happens all over the place. So now we didn't even get to our test. And so there are several things you can do then to sort of limit where this occurs. You can have where you don't want, what classes you don't want it to hit, where you want it to hit. There's also this other useful thing that I can say that I want it only to hit after it has passed another breakpoint. So that I could put up a sort of guard that I'm only interested in this exception after that point. So in this case, I will then come straight to my IO exception. So that's one way to do it. And this breakpoint up here didn't even suspend; it just needed to pass it. Yeah. All right. So now we get into the fun stuff. So say you have like some error from your client, and you have a request to your system that does not really fit into your local setup or whatever. You can then do some things to cheat and affect how this works. For instance, we saw in IDEA that we could get into the private stuff. We can see here in Eclipse that when things are supposed to be immutable or final, that's not the case, because for the debugger, this is just objects lying out there and somebody used them. And so we actually have full access. So one way, of course, to affect the flow is to change the data in your program. So for instance, here we have something like, we could play with the internals of big decimals, or we have a currency. In here you have a string. I could even then say that, okay, I even change the contents of the string. So we mess with individual characters. So everybody in the system pointing to an OK will now be referring to SEK instead. So this is it's nothing stopping you from doing that. So that's one way. But say you don't have any data, like here we have an if test. We can do what's called force return. So I can supply another value to return from this method. If it's void, you can just do force return. In Eclipse, you need to somehow, usually in your editor, maybe you have a value, or I could just highlight this here and say where is it? Force return. So now, okay, yeah, maybe not so successful, but in another case then, Oh yeah, I'm in the wrong place. Let's step out. We're supposed to be in here. So now I do force return. Yeah, okay, something went wrong, but you can then supply a different value. If it's void, it will return immediately. If you use IDEA for a non-void method, you get a prompt where you enter the value. So that's another way. Or if, for instance, if you're back here in the test, say that we had some validation code further down here that we did not want to hit or something else. Here we can then also just do force return and skip all of that and continue the program. So those are ways to overcome things and mess a little bit. Yeah. All right. Now we see in the traditional stuff for debuggers, I'm setting breakpoints, doing steps in code. There's also good functionality for keeping track of both classes and individual objects. So, for instance, in Eclipse, I can set a. Let's just see if I had. I can set a class load breakpoint, and that should. Yeah, so the first time we enter something that refers to this class, we'll have a class load breakpoint. In IDEA, you don't have class load breakpoints, but you could if you had like a static variable, a static final constant or something in your class. You could place a breakpoint there because that code will then get called when you load the class. So you can basically achieve the same. In addition, we have here something called memory view, which keeps track of your classes. So here you could also figure out whether a class has been loaded or not. You can find interface classes as well. These are not classes in your IDE. These are actual classes that have been loaded and are running in the virtual machine. You can also do stuff like say you're looking for an object with certain characteristics. You could say I want strings longer than 500, for instance, and then track down those objects. So if you had some domain class with an ID or something, you can then get a hold of that. Yeah, both IDEs have the ability to see all the instances of a class. You can create watches from here and so on. You can also, in Eclipse here, you can say that you can add a column. Let me see. I could also add a column with instance count. So in this case, for all the objects, I will continuously see the number of instances of that class integrated in the view. For NetBeans, you also have a class unload breakpoint. But the class breakpoints can be good, for instance, if you have a web app and you're not sure if things are loaded, or you're doing component scanning in Spring or something like that. So then you would, maybe in Eclipse, you could do a class load breakpoint. In IDEA, you could then, if you have any static initializers, use them, or use this data view to see whether the class has been loaded. Yeah, I guess that's the classes. Yeah, for individual objects, So I assume this. Yeah, okay. So what I did here was, that was a bit early, but we have an object here, and if I want to, wasn't supposed to make that yet. Forgot to unset some stuff. Let's see, just get rid of, just toggle this off for now. Let me see. Okay, so for dealing with the individual objects, we have here, we have an object, and I'm interested in, so I place a modification watch point on an instance variable because something is happening in my program, suddenly a value has changed. I want to know who did it. And you can, when you have then a variable like this, I could say that I want a breakpoint only to apply for this object, not other objects in the class. It's this one I'm interested in. So you can do that. So now we have a setting of the value. Yeah, and there's of course forgot to. Yeah, so I stepped over this line because this was another object. But when I do set value on this guy, it will hit that breakpoint. You can also make breakpoints thread aware. So you're only interested in what occurs in one thread. Yeah, also another thing is references, similar to what we had with all instances. You can have inward references to an object. For instance, if things are not garbage collected or something, you want to know who besides me is tracking this guy. And you can also incorporate that into the variables view here, so that for each object, in addition to the fields of that object, we also see the references marked by a special icon here. So they're represented side by side in your viewers, so you can traverse them in reverse, and also look at the contents of those objects. The thing I mentioned in IDEA here, we have not exactly the same. If I then allow this code to proceed, we can see that this class we're working on, it also, for every time the debugger stops, it will calculate if there's a change in the amount of instances if you want to track certain classes. So here I get a link, and I can also then view who instantiated this guy. Can get a stack trace. You can also, of course, place a breakpoint in the constructor. In Eclipse, you often are able to access the default constructor even though it's not in source code. In IDEA, you could typically place a breakpoint at the class. It turns out that if I had a breakpoint here on this line, that is also the default constructor appears to get this line number in the implementation. So if I redid this, oh, maybe not. Okay, I've been successful in the past, but not now. Yes. Let's see if we have the objects. Yeah. In IDEA and in NetBeans, you have this nice feature that so you have. Let's see. Oh yeah, no, it's sorry, it did hit the constructor. Just it's probably filtered away too much here. Yeah, okay, there we say init. So it applies still. So if I ever get here, oops, it's too many. Let's just get rid of that one. Okay, so we have an object. You will notice, you probably have when you've been debugging, that every object that you deal with in the debugger has assigned, the debugger will assign a unique number to it, which is the way you can distinguish between, if it's this instance or that instance. So in the past, I would often, have a pen and paper beside, noting down the different structures and so on. You can also do what's called mark object. So I can say this is my object, and within this debugging session, that simple 996 will be also labeled with a red label, my object. Especially if you're traversing structures which may be recursive, it can be helpful when you figure out that you were just back where you started. And you see if I mark this object here, you will also see it in the stack here, because the receiver here is this object that we have marked. So you can also then follow it there. So that's simplifies a lot when you're dealing with different objects. Yeah, I guess that's more or less it. Yes. There are some ways to make your life easier. When it comes to, for instance, some objects are pretty nasty to look at. So I have a tree map, which is a structure that's terrible to navigate. I have a XML document. I have a linked list, which just goes on forever and forever. And then you have this option called some logical structures. So now the list appears as elements here, and the map like this. In IDEA, there's a setting called alternate representation of collection classes, which is more or less the same. In addition, you can do the same for your own stuff. So there is something called logical structures. So you can create these snippets for your own classes if you want the hierarchy represented in a particular way. You can also change the way that things are formatted. So I can write this little snippet. I think the default for maps is quite okay, but I have added something to present each line by line. Maybe I did something in my script. I will not figure that out right now. In IDEA, you can also, if I have an object, like for instance here, I could say that I want to customize this, let me say, in some way, so that I instead of the default will be to string, and I've seen cases where you have to string method that calls some lazy initialization and things will change and so on. So then you could use, or if you spend a lot of time expanding your object looking for certain characteristics of each object, you can have then your custom render so that you see everything immediately in your variable structure. I see I'm more or less out of time, so I think we leave it there. I can just provide some references. I think the help system in the IDEs are generally good. There's a YouTube video IDEA did quite a lot about a year ago that you can look into. I've also done some talks looking into how debuggers work. So there's a video of that if you're interested. And then there's this video of our company. Anything I can help with? Any questions? Yeah. 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 Responsible for creating the strings. Yeah. Well, that's something as general as string is basically a lot of work. I mean, if you knew that, for instance, the strings would contain something special, you could search for certain strings and then follow the references back. But I think that would be quite heavy. But if you're if you go and make yourself a cup of coffee, maybe you could track them down. And you can also filter here. So like I could do like if I'm only interested in some stuff. Yeah, so it's usually, and you can also say something. You can choose the track classes, and you can say show track classes only. So you pick a few, so you don't have the whole list. Yeah, or you can do non-zero diff, so you're only interested in the stuff that changes. So you can limit it a bit, but it's if you something as general as string is maybe less precise then. So maybe just for the video, the question was how to figure out how, for instance, who instantiated a string, how to find out that. And any other things that you would like? All right, then I would like to thank you a lot for your time.